So I was completely unable to discover my favorite mathematical reference that just utterly dispenses with the notion of rule in defining a function. And in fact, most textbooks you're going to look at, in fact, pretty much all of them, are going to say that a function, the first thing they say about it is a rule. However, I'm going to say you don't need the word rule, so we can define everything we want without ever using the word rule. And arguably, the word rule is not a mathematically defined idea. How would you find a rule for, you don't want to say that this is not a sequence. It is a sequence, right? Especially if I don't have the dot, dot, dots. It's a finite sequence, all right? But what's the rule? Right. So I discussed this with another mathematician once, and he said, well, it depends on what you mean by rule. And I said, yeah, that's because the word rule does not mean anything. Anyway, I'll let you be the judge of that. And as you go on in your mathematical career, you can think about whether a function really is a rule or it's just a set of ordered pairs and we don't need the word rule. That's what I think. Anyway, so let's say now that we have a sub n, which is a geometric sequence. And by the way, I'll keep looking for that book. It's a lovely book. Just I can't figure out which one it is. Anyway, it's bugging me a lot. So let's look at the nth partial sum of a geometric sequence. We're going to develop a formula for it, and I want you to make sure that you've seen a clear presentation of where the formula comes from. So if I sum up the first n terms of a geometric sequence a sub n, say it's 3, 6, 12, 24. All right, so I'm going to start with my first term, and then my second term is going to be a1 times r. And my second term is going to be this times r, so it's going to be a1 r squared, right? Just keep multiplying by r every time. All right, so we keep going like that. And then you keep going until you get to, a1 r to the n minus 2, and then a1 r to the n minus 1, which is actually the last one, right? Because again, the n minus 1 is part of that formula for the nth term. The nth term is a sub 1 r to the n minus 1. So this one's r to the n minus 1, the last one. So to get to that nth term, you're going to multiply by r n minus 1 times. All right, that's what S sub n is. Now, what if I just take that same expression and just multiply it by r? Why? Because it works. So if I just take all these terms up here and multiply them by r, I'm going to have a sub 1 r, right, if I multiply this by r. So I'm going to just put that over here. And when I multiply this one by r, I get a sub 1 r squared. So I'm just going to put that one over here. So you can see I'm going to be lining up terms, and it's going to keep going like that. And then we're going to have a1 r to the n minus 2, and then we're really doing a1 r to the n minus 2 times r, which is going to give us a1 r to the n minus 1. And then we actually have one more because we're just taking all these terms and multiplying them by r. So this term is going to show up at the end plus a sub 1 r to the n. All right, so there's one expression for S sub n, one expression for r S sub n. All right, maybe I can zoom up a little bit so we can get all that on screen. All right. Yeah, that barely works. Okay, so here's the clever thing that we do. We subtract them. Subtract these two. Then what I get here is S sub n minus r S sub n equals, so the a sub 1 brings down, and of course all these are going to cancel out because I'm subtracting them. And then I'm going to have this one left over, but since I'm subtracting it, it's going to be minus a sub 1 r to the n. So all these terms basically just cancel out. And the expression telescopes down to just these two things. All right, zoom it down a little bit to be clearer. So now what we do is just solve this for S sub n. So S sub n times 1 minus r. We do factor the S sub n out. Equals a sub 1 minus a1 r to the n. So that means that S sub n equals a1 minus a1 r to the n over 1 minus r, and then traditionally we factor out the a sub 1 from the top. S sub n equals a1, 1 minus r to the n over 1 minus r. So this formula is the summation of a geometric sequence. It's going to be extremely important to us in the next section. Summation of geometric sequence. All right. So for example, we could say, what is... let's find the sum of the first 10 terms of the sequence that goes 1/2, 1/4, 1/8, 1/16. So you're usually used to thinking of geometric sequences as increasing, right? So they go like, for example, 2, 4, 8, 16. But this is also a geometric sequence, right? A sub 1 equals 1/2 and R equals 1/2. So if I have an R that's less than 1, the sequence decreases instead of increasing. That's the kind of geometric sequence we're going to be really super interested in. All right, so what's the sum of the first 10 terms? Well, S sub 10 equals our A1, which is 1/2, times 1 minus R to the n, which is going to be 1/2 to the 10th power, over 1 minus R is 1 minus 1/2. So I get 1/2 times, well, let's see, 2 to the 10th is 1,024. So 1 minus 1 over 1,024 is going to be 1,023 over 1,024 over 1/2. Cancel the 1/2s, and we get that this equals 1,023, 1,024. That is the first sum of the first 10 terms of this sequence. Interestingly, very close to 1. And that's something that's going to really interest us quite a lot as we go forward. Okay. Yeah, so the next thing we're going to talk about is limits of sequences.